So we're going to talk about the greatest integer function and piecewise function. So I'm going to probably split this into two videos so it's not quite so long. And the greatest integer function, sort of as far as I'm concerned, is a misnomer, but it's also known as the step function or the floor function. And I think the term step function is good for the graph, and the floor function is good when you want to think about what this actually means. The function looks like this. It sort of has that double-backed bracket. So when you take a look at you should be able to fill in your blanks on your class worksheet as we go along. So you're going to take the input and find the, it's not coming up for me here. Let's move this to the back. Okay, so it's going to find the greatest integer closest to that number without going over. So I think it's not bad. It's not too difficult to think about when you're thinking about the positive numbers, but the negative numbers can sometimes give us a little bit of a problem. So what you want to really think about is, if you've ever watched The Price is Right, remember that you don't win if you go over the price. So you want to always stay underneath the price. So that's what's important there. So for example, this indicates that I'm looking for the greatest integer that's no bigger than 7.35. So that should be just 7. Because if I put an 8 in, then I've gone over the 7.35. Here, if you think about what that fraction is, it's 1 1/3. So I have to go, it's sort of like rounding down. So I have to put in my answer is a 1. The greatest integer, now this is where it gets tough. You want to think about negative 2.5 on the number line. If I put negative 2 as my answer, negative 2 is bigger, so I've gone over the negative 2.5, so I have to round down to negative 3. And this fraction simplifies to be negative 2, so I can actually use negative 2 because it's okay to be equal to, it just can't go over that value. So let's look at what this means for this parent graph. And again, here's the idea that the greatest integer function got its nickname, step function from its graph because it looks like little steps. So I start putting in x values, and notice I'm going to look at a lot of decimals in this one. And so the parent function, if I put it in negative 2, the number that doesn't go over that would be negative 2. If I put in negative 1.75, I have to round down to negative 2, because if I put in a negative 1, that's bigger. And really, negative 1.5 is going to round down to negative 2 as well. So if you're having trouble sort of visualizing that, if you have your number line, and here is your negative 1, and here's negative 2, all of these numbers fall in between negative 2. Let's put this here. So they fall between negative 2 and negative 1 on the number line. And so if I am looking at, say, negative 1.5, well, negative 1.5 is somewhere about here. If I put in negative 1, that number is bigger. I've gone over negative 1.5, so I have to round down to negative 2. And it's going to be that way all the way until I get to negative 1. Once I'm at negative 1, I can then keep negative 1. And again, I've got to round down to negative 1 for that negative 0.75, and round down to negative 1, round down to negative 1, and whoops, there's a typo. I don't need negative because 0 doesn't have any sign. So that will be 0. And all of these until I get to 1 are going to round down to 0 as well. So if I fill in this chart all the way, you can see where we're going to use the same output for many of the numbers, so that should indicate the idea of using a horizontal line. And what I've done here is the part of your graph that that we're going to put on this graph paper here is right here. So if at -2 it can equal -2, so I put in a -2 and out comes -2. So it works there. And notice that -1.75 is in here, and it will also be -2. So all the way up until I get to -1. Now once I'm at -1, then when I'm going to jump in value up to -1. So this will jump up here to -1, -1, and all the way to 0. And notice what's happening is, you see where the name is coming from. You've got little steps, little baby steps here. So this step function, I guess I only went up to this section right here. So this is what the parent function looks like. And I would like to have probably 5 of these on here when you are graphing the parent function. So, so that you have really kind of, if you want to think about it, it starts at 0, 0 again, and you have 2 to the right and 2 to the left. So the next part is to talk about transformations. How are you going to transform? All these parent functions use the same transformations. They don't change. So the graphing form for the greatest integer function is f of x equals a, and then the greatest integer function notation, b times x minus h, in parentheses, close that step function notation, plus k. So hk is the starting point for the steps, just like it's the starting point for the parabola and the cubic. Now the length of your steps comes from this b. If that b happens to be 1, then your step length is 1. But if it's something other than, if you have a 2 here, then your step, the length of your step is 1 over 2, so it would be just half a unit long. The space between your steps vertically is going to be this number a out in the front. So if that a is just 1, then you're going to step up one unit at a time, like we did on the first one here a minute ago. So the other important thing is, if a is positive, the steps are going to go up to the right, which makes sense. And if a is negative, then your steps are going to go down to the left. So fill in all of that information in the class notes that you have.